Good day, ladies and gents. Today we are going to be doing day 2 of our end of course exam review. All right, so let's just get started. All right, so we are doing equations of lines. Fill in the chart with the correct slope of the line parallel or perpendicular to the given slope. All right, so let's talk about a little bit of notes here. So first of all, this symbol right here means parallel. And parallel means that you have the same slope. So same slope. Whereas this is perpendicular and means that you have a negative reciprocal of the slope. Basically, you flip the sign and you flip the fraction. You have to do both of those. Flip the sign and flip the fraction. And if you don't already have a fraction, you have to make a fraction. All right, so those are basically the two rules. All right, so with that idea, let's put that little bubble right there. All right, so now with that idea, okay, so right now, this right here wants parallel. So we need to have the same slope. So our slope would still be that 1 over 2. This one right here, perpendicular. You have to flip the sign. Okay, so this is a positive right now, so it would turn into negative. And you flip the fraction, would be 3 over 2. So it's negative 3 over 2. Now this one, right now, our slope is 3. So our slope is 3, and they want parallel. So that means that we just want the same thing. So it would just be 3. So, and then over here, right now, this is negative 4. We want perpendicular. You have to flip the fraction and flip the sign. So flip the sign, that's pretty easy. That turns into a positive. But the fraction, we have to flip the fraction. This isn't a fraction yet. So you have to put it over 1. So flip the sign, boop, that's positive. Flip the fraction, that is 1 over 4. And a positive 1 over 4, the easier way is just saying 1 over 4. If you put positive 1 over 4, that will not be acceptable because the positive is not really doing anything. Over here, this is perpendicular again, so you have to flip the sign, so that turns to a positive. Flip the fraction as well, that's 5 over 1. The positive is not doing anything, and the 5 over 1, that's just 5. So 5 is the best answer. So all right, so let's talk about a couple things. All right, so if you put positive 1/2, that would be wrong. Over here, right here, if you put a positive 3, it's wrong. If you put a 3 over 1, it would be wrong. If you put positive 3 over 1, it would be wrong. So I'm just pointing out some things that some people accidentally do without realizing it. So these are the best answers. All right. Number 2. All right, so number 2. All right, so number 2. Line F has the equation of y equals x plus 4. Line G is perpendicular to F, and it passes through this. Now, there are multiple different ways how to do this. So no matter what, everyone definitely has to go find the slope. So let's talk about that. So slope. So the first thing, we want to talk about the slope. So to find the slope, right now, y equals mx plus b, where m is the slope. That is m, right? All right, so at this very second, we have y equals x plus 4. Now, there's supposed to be a number out front, so what's this invisible number out front? That's a 1. So right now, our slope is 1. So m equals, and that is a 1. Now, we want perpendicular, so we have to make, what's the sign? Right now it's a positive 1 over 1. So we have the sign and we have the fraction. So what would be the perpendicular slope? The perpendicular slope, flip the sign, negative, flip the fraction, that's 1 over 1. So is there a better way to say that? Yeah. The better way to say that is just negative 1. All right, so that is our slope. The next step is the y-intercept. So y-intercept. So what we're going to do is we have y equals mx plus b. We're going to plug in everything else that we know and solve for b. So this is my x, this is my y, so I'm going to plug in this. So we have 3 equals my m, which is now negative 1, and my x, which was 2, plus b, and you would solve. So 3 equals negative 2 plus b. You would solve for b, add 2 to both sides, and you get 5 equals b. Your final step, write out the equation. Y equals mx plus b, where all we want is your m and your b. And it's what those other two steps you just found. So y equals negative 1x plus 5. And then you clean that up if you can. You see that negative 1x? That 1's not really doing anything, so it's just y equals negative x plus 5. So this is one way how to do this. A second way of how to do this is by using a graph. Just use a graph. That's pretty nice. So let's start with this. We have, at this moment, we know for a fact that we are going to hit this point, 2, 3. So 2, 3. 2, 3. We know for a fact that we're going to hit this point. Now, no matter what, you're stuck with trying to figure out what your slope is, right? So your slope was 1. You flip the sign, flip the fraction. So from here, we're going to go negative 1, 1. So we found our slope. No matter what, you're stuck with doing this first step. We know that we hit this point, and we know our slope is negative 1 over 1. So go down 1, run 1. You go up or down, but always to the right. So down 1 over 1. Down 1 over 1. And if I go in the other direction, up 1, back 1. So I'm just continuing the pattern. Hey, look at that. I know what y-intercept is. So where's this point right here? That's at 5. So we now know, so instead of doing this step, we could have just done this, and now we know what the y-intercept is. So once you find the slope, use this point, keep up the pattern to find your y-intercept. So either for the y-intercept part, you could either use this equation or you could do the graph. And then your final step is this equation. So that's a good little pattern right there for number 2. All right, so if you have to, no matter what, you find the slope, you're stuck with that. 2 ways to find the y-intercept. One is algebraically, the second way is graphically, and your final step is definitely make that equation. All right, sweet. Let's go to number 3. All right, so at number 3. Okay, so at this moment, we need to find what is the equation of line H, right? So we have this equation. Line H is parallel to line G, and it passes through this point. All right, so no matter what, we want to find the slope first. So slope. All right, so at this second, we have y equals mx plus b, and what we have is y equals negative 0.25 x plus 5. So our m at this second is this right here. So our m at this second is negative 0.25. Now, they want parallel, but we actually need to know what that is. We actually need to know what this fraction is. So another way of saying this is negative 1/4. Because that's, like think of money in dollars. That's cents, right? So it's 25 cents. That's a quarter, 1/4. So it's negative 1/4. And then if we want the parallel means same, right? So parallel would still be negative 1/4. So m equals negative 1/4, and I circle that. So that's my slope. All right, now to find the y-intercept, there are 2 ways that we could do this. One way is algebraically. So y equals mx plus b. So we now know that this is m, and now let this be x and this be y. So if my y is 4, my m is negative 1/4, and my x is 8, all that plus b. 4 equals, we would multiply this, negative 1/4 times 8, if you put that in the calculator. Negative 1/4, and you multiply by 8, we get negative 2. So we get negative 2 plus b, we would add 2 to both sides, and we would get 6 equals b. Now the other way to find the y-intercept is graphically, right? So let's do this by graph. So if we did this by graph instead, we know for a fact that we're going to hit 8, 4. So over 8, up 4. 1, 2, 3, 4. There's 8, 4, and I know my slope is negative 1/4. So I would go down 1 and to the right 4. But I can't do that because it goes off the graph. So I'm going to go up. So so I know it's somewhere over here. So down 1, 1, 2, 3, 4. So somewhere over here. So it'd be going like this. All right. So undo that. Up 1, back 4. 1, 2, 3, 4. Do it again. Up 1, back 4. 1, 2, 3, 4. Up 1, back 4. 1, 2, 3, 4. Oh, look. I actually know where my y-intercept is. And guess what? It's at 6, just like I said a second ago. Isn't that nice? All right. Awesome. So we found our y-intercept, which was that. And the final step is write down the equation. Y equals mx plus b, where you're plugging in your m and your b, those two things that you just found a second ago. So we have y equals negative 1/4 x plus 6. All right, so let's write out the equation. Y equals negative 1/4 plus 6. Okay, now this is a problem. I did something wrong. What did I forget? Oh, that x. That's a very common mistake. So make sure that you put that x there. And that's the equation. Fabulous. All right, let's keep going. Number 4. All right, so on number 4, we have this. Line S, the equation of y equals negative 3 over 8x plus 4. We want something perpendicular to this line, and it passes through 3, 3. All right, so let's think about this. There are multiple ways how to do this. One way is this right here. So no matter what, we have to find the slope. That is definite. That's never going to change. You're always going to have to find the slope first. So at this minute, our slope is slope. Oh, I should do that in blue. So our slope at this second is negative 3 over 8. So what would be the perpendicular slope? You would have to flip the sign, that's positive, flip the fraction, and we get 8 over 3. So our slope right now is positive 8 over 3. That's very, very important. All right, so we have that. So now we want, and we have to pass through 3, 8. Or sorry, 3, 3. So there's two things that we can do. One is we can do it algebraically, or and actually find the equation. That's one thing we can do. But another thing that we could do is actually figure out what points we would have, right? So let's see. Right here, number 4. We know for a fact that we are hitting 3, 3. So there's that. So that's going to be one of our points. I'm just going to list my points. Sound good? All right, so I know for a fact I hit 3, 3. That's my x, that's my y. Let's see if we can find some other points. So I know I'm going to go up. I'm either going to up or down. So I'm going to go up 8 over 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Now that went off the graph, but let's go the other direction. Let's go down 3. Let's go down 8, back 3. 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3. Oh, look at that. We actually found our y-intercept. Isn't that nice? And it's a beautiful number, and that is 0, negative 5. So that's another point that you definitely hit. So these are 2 points that we know that hit. Now here's the awesome part. One of these or more, because they say select all that apply, are going to work. So this is what's going to happen. I'm going to plug in these 2 magical coordinates one at a time. And if they work, that's awesome. If they don't work, then it's no good. So let's check this out. Okay, I'm going to try this 3, 3. This would be my x, this would be my y. And then later on, I'm going to try the 0, negative 5. That will be my x, my y. Just trust me, just watch how this works. So here we go. If I plug this in, this is my x, this is my y. If I plug this one in right here, I'm going to make these lines here so you can follow my steps a little better. So right here, if I plug in this for my y and this for my x, okay, so does 3 equal? Now if I plug this into my other side here, that would be 8 over 3. I'm multiplying by 3, which is my x, and I subtract 5. Does that equal 3? Yes, this is still happy. Now, does the other coordinate work? If I plug 0 in for x and negative 5 in for y, so that would be negative 5. Does that equal 8 divided by 3 times, and I'm plugging in 0, subtract 5, and I got negative 5. So both of these work. So this does work. Let's try this other one. If I plug in 3 in for y, does that equal, and I'm plugging 3 in for x. So clear this. That is negative 3 divided by 8 times this 3 plus this 8. Does that work? 6.875. No, it does not. And I'm not even going to bother finding the other one. So, because if one doesn't work, then I'm not happy with this. Let's keep going. All right, so this one, 15 plus 3 times my y is 3. I got 24. Does that equal 8 times 3? Yes, it does. All right, so let's make sure the other point works as well. If I plug in 0 in for x and negative 5 for y. So 15 times that negative 5. Wait, let me try again. 15 plus that 3 times negative 5. That's 0. Does that equal 8 times 0? Yes, it does. So this one works as well. Boom. We got those 2 points. All right, and this one. Okay, 16 times plus 3 times 3. Does 25 equal 5 times 3? No, it does not. So this doesn't work. So we only have these 2 points that work. So that's definitely one way. So this, I think that's the best way you could do this. The other thing you could do is actually take the time and find each one of those equations. Here's that other way right there. A little more time consuming right there. You would have to take each equation. So we would find this equation right here. Already you're starting to cry. So this is the slope. We found this. You found the y-intercept by plugging in this coordinate right here, and we get negative 5, which we found earlier. And so this is the equation we want. So you would have to take each one of these equations and see if it is this. So that works. This one right here, that doesn't work. That's not that equation right there. This one, you would have to take the time to find that equation. So you see here I'm solving for that equation, and I get the same equation right there. And then D, I would have to solve for that equation as well, and it just won't work. So I didn't take the time to find that, but yes. All right, so I was just showing you a couple other ways how to do this, but I think this is pretty much the fastest way. So this is the fastest way that you could do this. Just find those other points by finding the graph, which we just had to do this right here. Find one other point on this graph, and then your life is super, super awesome. All right, so here we go. And number 5. Number 5 right here. Okay, is it parallel, perpendicular, or neither? All right, so there's a couple different ways how to do this. One is you can actually solve these equations. So let's go ahead and take the time to do that real quick. So I'm going to show you the harder way. So on this one right here. All right, so this one is still y equals 3 over 5x minus 3, right? Now this one, if we take 5y equals 3x minus 10, and we need to solve for y. So this one's pretty easy. You're just going to take that 5 and divide each individual by 5. And we get y equals, that is 3 over 5x minus, and what's 10 divided by 5? That's just 2. So we have y equals 3 over 5x minus 2. So look at the slopes. Are they the same or are they different? So they're the same, so that's definitely parallel. That's definitely parallel, so that is the answer. Now, if you did not feel comfortable with this, if you're like, oh, I totally forgot how to do this, another way you could do this was totally to graph this. All right, so if we graph this one right here, so if we plug in, so our two equations, right? We have y equals 3 over 5x minus 3. All right, so if I plug in x equals 0, what would you pop out with y? You would get, if you plug in 0, y would equal this times 0 minus 3, and we would get negative 3. Now let me show you that, just in case just in case we have other languages going on here. You don't know what I'm talking about. Okay, 3 divided by 5 times 0. And we're subtracting that 3. And look at that. We got negative 3. So if x is 0, we got y is negative 3. That's what happens, right? That's what you just found. So one of the coordinates that we have is 0, negative 3, right? Okay, so now we just need to plug in something else. Something else. And you see how our denominator is 5? 5 would probably be a really good number. So what if we let x equal 5? Okay, plug that in. So 3 divided by 5 times 5, and we're subtracting that 3, and we would get, oh, cool, 0. That's nice. Y would pop out as 0. All right, so we have two coordinates here. We have 0, negative 3, and we have 5, 0. And then how do we get from here to here? We went 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. And you just keep up that pattern as much as possible. Now, let's do the other line. So on the other line right here, just plug in those same points. Plug in the same points for 0 and 5. Let's see what we get. All right, so if we have y equals, 5y equals 3x minus 10. Should make this red this time. All right, so we're just going to plug in some random points. So let's try 0. 0 is a pretty easy number. So if I plug in 0, what would we get? So if I plug in 0 into this, what would y equal to? So if I could do that, I would get 5y equals 3 times 0 minus 10. 5y equals 0 minus 10. 5y equals negative 10. Y would equal negative 2. All right, so that's one of our coordinates, 0, negative 2. All right, so now you just have to plug in something else. So another good point that you could totally input would be, let's see, we already plugged in 0, so let's try 5 again, because that's what we did earlier, right? So what if I plug in 5? If x equals 5, what would we get? We would have 5y equals 3 times 5 minus 10. So I'm just plugging that in, see what I get. I get 5y equals 15 minus 10. 5y equals 5. Y would equal 1. So that's another coordinate. We have 5, comma 1. All right, so let's see what we get. So we get 0, negative 2, and then we got 5, 1. And how do we get there? We went 1, 2, 3, 1, 2, 3, 4, 5. So do you see that pattern? We would just keep up that pattern over and over. And look at that. What kind of lines do those look like? Those look parallel. So so this one was super faster, but this one is just in case you can't remember how to do that one part. So parallel was the answer no matter what. All right, fabulous. Okay, let's go ahead and go to part 2. Let's go to part 2. All right. Okay, parallel lines and transversals. So we want to know these rules. Okay, so corresponding is a copy-paste job, such as this is the top left corner. This should also be the top left corner. So that's like a copy-paste. Alternate interior. So the train. So you want to see if you're on the same side or alternate sides. So on the train, are you on the same / alternate sides? And then, so same or alternate, and then you want to see, are you interior or exterior, right? And what does that mean? Okay, so interior is this right here. Interior is inside the sandwich, whereas exterior is all this right here. All right, so interior is in here, exterior is out here. Okay, so that will narrow down your search. All right, so here we go. So on this one right here, so I'm going to call this A, B, C, D, E, F, G, H, just so you can see what's going on in my head. All right, so for A, all right, so if we're talking about 4 and 7, so here's 4, here's 7. So 4, 7, so it looks like this. 4, 7. So this is 4, this is 7. All right, so we're going to turn this until these two lines are horizontal to us. All right, are they on the same side or alternate sides? They're on the same side. And they're both on the interior. So that's interior. So that's same side, interior. All right, let's try B. All right, so for B, we have 2 and 11. All right, so 2 and 11. So here's 2 and 11. Are they on the same side or alternate sides? They're on the alternate side, so that's our first word. So alternate, and are they both inside or outside? So just do your best to like cover everything else up so we're not focused on it. So 2 and 11, they're on alternate sides. That's our first word, and they are both exterior angles. So they're both exterior. So that would be our second word. So alternate exterior. So 211, alternate exterior. Awesome. All right. So for C, we have 12 and 16. Here is 12, here's 16. So we turn this, cover everything else up. Here's 12, here's 16. So we want here and here. So 12 and 16, are they on the same side or alternate sides? They're on the same side. So 12 and 16. Now, if I go like this, 12 is interior, 16 is exterior. So interior, exterior. So those are two different things. So that doesn't work. You can't say the same word. So, but if I look at it this way, here's 12, here's 16. I can copy paste that and they're in the same position right here and here. See how they're both at the top right corner? So that really is corresponding. So corresponding is the answer for that one, for part C. All right. Okay, next part. All right, we're going to do 8 and 13. So for part D, 8 and 13. So here is 8, here's 13. So I cover everything else up. So there's 8, there's 13. Are they on the same side or alternate? They're on the same, they are on alternate sides. So that's the first word. So alternate for D. Okay, then for 8 and 13 right here. So we're doing 8 and 13. So 8 and 13, they're on alternate sides and they're both inside. Those two lines right there, they're both on the inside. So that is interior. So that's alternate interior. Boop. All right, 11 and 15. All right, so for 11 and 15, there's 11, there's 15. So we're going to cover everything else up. And so there's 11, there's 15. 11 and 15. Okay, they're on the same side. So that's the first word. So for 11 and 15, they're on the same side. And 11 is exterior, but 15 is interior. So that's exterior, this is interior. So we can't use that word. So how about copy paste? So let's see. Here's 11, here's 15. Yeah, they're both at the bottom right corner. They're both at the bottom right corner, so we can use corresponding. So 11 and 15 is corresponding. Okay, next we have 7 and 10. 7, here's 7, here's 10. Now hold on, there is no train going from one to the other. We need one train going from one to the other. There is no train going straight from one to the other. So that one right there is none because there is no transversal. We do not have a direct transversal going from one to the other, so that definitely does not work. Okay, so 12 and 15. So 12 and 15. Here's 12 and 15. If we cover this up and we turn, so 12 and 15 right here. Okay, so we have 12 and 15. They are on the same sides. That's the first word. So that would be same side. And they're both on the inside. So that's same side interior would be that one. So same side interior. 12 and 15, that's same side interior. Okay, and finally 6 and 7. All right, so if we look at a picture, here's 6, here's 7. All right, so going from 6 to 7, we cover everything else up. Here's 6, here's 7. Okay, they're on alternate sides. That's our first thing. So alternate sides. And then now 6 is exterior. 7 is interior. So those are two different things. So I can't use that, right? So that doesn't work. All right, how about corresponding? Are they in the same position? Let's see. So 6 is right here, but 7's right here, and they're not in the same position. This is the top right corner. This is the top left corner. So corresponding also does not work. So this would be no relationship. So that'd be none. And those are the answers for number 1. All right, next. Okay, number 2. All right, so number 2, they're saying which one's a supplementary. Now let's talk about supplementary. Supplementary means that they add up to 180 degrees. That's the goal, supplementary. So that as long as they add up to 180 degrees, it doesn't matter where they are. Now, if I say linear angles, that'd be something different. Or a linear pair, that'd be something different. So we're just going to make something up. So we're going to make something up. Let's say that this was 80. This would be 100 then. So if I knew that this was 80, just making this up, then this would have to be 100. That would be 80. This would be 100, and then copy paste. So you see the top left corner is 80. This would also be 80, 100, 80, 100. Okay, so now take this and put it in here. 8 is 100, and 6 is 100. Does that make 180 degrees? Nope. So that doesn't work. 1 is 80. 2 is 80. Does that make 180 degrees? Nope. Okay, how about 2 and 6? 2 is 80. 6 is 100. Does it make 180? Yes, it does. All right, 1 is 80. 5 is 80. Nope, that makes 160, so that doesn't work. All right, how about this? 1 is 80. 4 is 100. Yep, that works. 3 is 100. 8 is 100. Nope, that does not work. We need something that makes 180 degrees. Okay, 4 is 100. 7 is 80. Yep, that works. And then 7 is 80. 5 is 80. That does not work. So those are the only 3 that work. So this, and this. Now, if I said, example, if I said linear pair, that would be a different answer. So a linear pair would have to be that they make together they make a straight line. So would 2 and 6? No, because they jumped. So 2 and 6 would not work. How about 1 and 4? 1 and 4, yes, together they make a rainbow of a straight line, so that does work. And then how about if I said 4 and 7? 4 and 7, that would not work. So this is just another little bubble thought. So if they said linear pair, they would have to make a rainbow of a straight line. So I was just pointing that out. In this case, these were the only answers for this particular one. All right, let's keep going. Number 3. All right, so on number 3 here. All right, now this picture is really, really sketchy because everything looks like they're 90 degrees. So what I highly suggest is before you start this, exaggerate the picture. So I'm going to make it look like this. That is a safer bet. Where this is R, V, S, W, T, U, Y, and X. All right, so all I did was exaggerate the picture. This looks like 90 degrees. I want this. All right, so now let's take this stuff and put it in here. We have TSU. So TSU, if I take my sticks, TSU is this angle right here. So here's TSU, and TSU is supposed to be 8x minus 14. So 8x minus 14, and we also know that VWX is this right here. That angle right there is 5x plus 34. Okay, so what do we notice about this? This is, see how this is acute? This is obtuse. So this is obtuse, right? So this is obtuse. And this is also obtuse. Or you could say this is big and this is big, right? Big, big. All right, so they're both big. So what do you think? Do they think they equal each other, add up to 180? So they're going to be equal. So we're going to set those equal. So 8x minus 14 is equal to 5x plus 34, and you would solve. We would subtract 5x from both sides. We get 3x minus 14 is equal to 34. We would add 14 to both sides. We get 3x is equal to 48. Divide by 3. 48 divided by 3, and we get x equals 16. And what are you supposed to do as soon as you find x? You always plug it back in. So let's plug it back in here. If we plug it back in, we get 8 times 16 minus that 14. We get that this angle right here is 114. 5 times 16 plus 34, that is also 114. Awesome. So we got 114 here and here. And we can actually find all these other angles. So 180 minus 114, this angle will be 66. This is 66. This is 114, 66, 114, and this is 66. Now we're ready to answer any and every question. They wanted VWX. Here's VWX. So VWX, that would be 114. They want RSW. Here is RSW. So RSW is this thing. Oh, look at that. They wanted 114 again. That's awesome. Okay, and those were the answers for that one. All right, sweet. All right, let's keep going. All right, and then this right here. Okay, and then final question. We have draw two lines that are transversal is 3, 4 are alternate interior angles, and that 2 and 3 are vertical. So basically we're saying that they need to be like this for alternate interior, and vertical means that they're like this. All right, let's see. Is 3 and 4 when I make a Z? Nope. 3 and 4. Now they would have to be, they said exterior, right? So exterior. That should be okay, because if I do my Z thing, they're on the outside, right? They're on alternate sides of the transversal, and they're both outside. So that one checks out so far. And then this one, 2 and 3. 2 and 3. Nope, that one didn't check out. So because of the vertical angles. So that didn't work. How about here? So 3 and 4, those are alternate, and they're both on the outside. So that checks out. And or 3 and 2 vertical. Yeah, that checks out. All right, how about here? 3 and 4. So let's change it this way. So 3 and 4, they're on the outside. So on the alternate sides of the transversal, and they're both exterior angles. So that checks out. And is 2 and 3. Nope, 2 and 3 are not vertical, so that didn't work. So the only answer that worked was C. And that is it. All right. I hope that helped you out on everything. Got you a nice little review. Have a great and wonderful day.